Um, so yeah, so today Martin and I are going to be sharing essentially some learnings from a hackathon we did a bit less than a month ago now. Um, and I guess essentially who we are, maybe let's start from there. So Martin is a founder. He started two companies before, co-founded two companies before, 11x and Crew. And I come from the machine learning side of things, and most recently I was at Apple. And I guess the context for us doing this kind of hackathon was that we both coincidentally uh, kind of left what we were doing. So I left Apple, and Martin has also left Crew. And so we both had kind of a more flexible schedule, so to speak. And Martin suggested, Martin had kind of signed up for this hackathon. He invited me, and neither of us really has a robotics background. I had done some robotics in university, but that's about it. Um, and as kind of Dave alluded to, the reason we're here is that we essentially wanted to get a robotic arm to practice with. And it turns out Dave is the only person in London who has one, and that gave him a lot of power uh, over the both of us. And yeah, we really wanted to get one because essentially, if we didn't, we would probably have spent like a decent amount of that competition's time just learning like the real basics. Um, and so yeah, we borrowed the arm. We spent kind of like a couple of days preparing, and then over the weekend we went to Paris. So the hackathon was kind of 2 days. Uh, the actual competition was really 36 hours. And I guess just a tiny bit of background, which some of you might already be familiar with this, but just in case uh, you are not. So the hackathon was centered around this arm, which is called the SO100 that Dave has shared some things about before. And this arm is kind of an open source project by Huggingface, which is kind of like a company that focuses on the open source machine learning, and now they're getting into robotics. And essentially, yeah, I'll talk a bit more about what was kind of the hackathon theme, but it revolved around this arm, and so it's also natural follow on to Dave's previous talk. And I guess some of the learnings are also related to vision language action models, which are um, kind of the latest trend in robotics, as I understand it, although, all of this is pretty new to me as well, which is essentially trying to take some of the learnings from computer vision and NLP and trying to scale up the robotics models on and pre-training them with data from the web so that they can learn more efficiently with fewer observations and fewer examples of robotic manipulation trajectories. And yeah, I'm just putting that here. I guess we won't go too much into it, but just if in case anyone is not too familiar with what is a robotic policy or anything like that, it's essentially a model that can see, it can get some text input, and then its output is essentially the sequence of um, uh, the motor sequence that the arm needs to follow. So this arm has kind of 6 motors, and so the output space of the model is 6 numbers that determine kind of the position of these motors. Martin, do you want to talk about our kind of
Yeah,
pre-hackathon?
No, no, absolutely. So as Emilios mentioned, neither of us have really played around with the SO100. So it was very nice to be able to play around with them. Just setting him up to be, following the moves I had was already very, very fun. But then actually training a policy is what really made a difference for our learnings. The couple of learnings that we found by just training a very simple policy, which was trying to pick up a particular item in between three other items, is it was super important for us when we're giving the examples and giving up or creating a data set to make very slow, deliberate movements. We started off with making quite fast, janky movements to pick something up, and we found that that didn't work very well. Also, because it was being done in my living room, the lighting situation seemed to change quite a lot during the time that we were there, and that was really affecting the performance of the actual policy as well. We tried out Oslo, which was one of the sponsors at the hackathon, and while it was interesting what they're trying to build, they're basically trying to build this kind of like abstraction layer on top of the Lenovo project to make it easier for people to train it, to what's it called, to operate it. However, we found it was a little bit early still. And also during the hackathon, people were trying to use Phospho. Even our teammates tried to use it for a little bit as well. And they still had some early stage startup well, issues, let's call them. I tried to train the Pi Zero model as well, but very quickly realized that my MacBook Pro has no chance of actually doing anything meaningful to that model unless we give it a couple of years. So GPU is definitely needed for that. And then finally, we also realized that ACT just it works. If you give it enough examples, it just creates decent policies. As long as you also don't try and confuse it with too many things within the scene, you're able to get something that actually works quite reliable. And those learnings were, yeah, super important to take into the hackathon to kind of, ground us, not just in what to do during the hackathon, but also really make sure we understand what the possibilities were, as well as the limitations of these SO100 arms. And then finally, it was super fun. Yeah, like just teleoperating these robot arms was like kind of magical in a way, doing it for the first time. So yeah, very much enjoyed it. Can you go to the next one? Cool, amazing. So yeah, we flew to Paris for the Mistral AI robotics hackathon. There were a bunch of really exciting partners there as well. Lightspeed, which is one of our better performing VCs out there. Entrepreneur First had a big role in organizing it all. Nvidia was there. Then Fossil was there. It was one sponsor as well. And it was a really it's a very well high signal or good group of companies and organizations there. Now they have a specific goal for us, building a real world robotics demo with the Mistral LLMs as well as the SO100 arm. And it was interesting. They only had three requirements, and they were quite they're quite easy, or not, at least not the right word. They're quite liberal. So we only had to make sure that the robot was doing a physical action using one of the LMs for high level understanding. So whether that's understanding a prompt you give it, understanding the environment, using a visual model, something like that, and then using a train policy, either using the robot or Phospho to help us with that. And obviously we did all of those things. We hit all of the requirements as well. And it the whole hackathon had a air where the kind of VCs wanted to push the idea that robotics and AI are kind of like at that inflection point, and that there's a ChatGPT moment coming where the barrier to actually do AI and robotics has become quite low. They had a talk about this at the start of the hackathon as well. The interesting thing to note here is that most of the or well every speaker that was on the podium kind of pushed back against the venture capitalists, saying like, we've come a long way, but there's not quite that ChatGPT moment yet. Like things are still quite difficult to like get exactly right. That kind of reliability that LLMs have right now, robotics isn't quite there yet. The inflection point might come somewhat in the near future, but there's definitely still some work to be done there. But obviously, models like Pi Zero are a very exciting step towards that. Cool. Should we do the next one? Cool, amazing. Okay, so yeah, this was our team. You can see we're all very very excited. We see Aimilios with a VR headset. I'm holding an arm, and everyone's very happy. What we built is a bimanual robot that packs your bag for robotics hackathon. And the way to imagine this is that you, instead of having one arm that's had policies trained to it, we actually use two arms, and we actually operate them independently, and we make sure they collaborate. One thing that we've done as well is we actually made sure to have like a little theme around it where one arm is actually Rick from Rick and Morty and the other arm is Morty from Rick and Morty, and they kind of talk to each other, collaborate with each other, and as you can imagine, they'll have some funny dialogue to tell to each other as well. We'll go into a little bit more of the architecture later, but yeah, we use Mistral for understanding the environment, for making choices on which things to pack, and then we have a couple of policies trained for each arm as well. And I think there's a video coming up next.
This is kind of our submission at towards the end of the hackathon. So there was kind of a few layers of judging. So it's kind of like first a video submission, and then there was a final with 6 teams where like the judges kind of went around. The first round was judged by mentors, so there was actually quite a large number of mentors in the competition from like a bunch of companies. And yeah, the second round was the judges, which I guess were the most credentialed of the bunch.
Yeah. We'll show the video, but then we got like a funny story to tell as well around how the demos went.
I'm not sure if the audio is going to work actually. I hope so.
That would be a shame.
Hi, we're Team 7. We're excited to show you our end-to-end.
Works?
Yep.
Hi, we're Team 7. We're excited to show you our end-to-end physical AI system for collaborative robots. And here's Rick and Morty to tell you about it.
Hey Rick, could you please grab me a motor and some tape for the hackathon?
I think I'll grab the black motor. Yeah. Cool. Motors are like important, right?
Right pick, Morty. You need the engine you're building chaos.
Oh man. Oh geez. These motors are more complicated than I thought.
Okay, right now we have a camera there that it is checking that the motor is in the box. And if it's not in the box, the robot will try again. And if it is, we will pass to the next step.
Oh geez. Rick, I guess you gotta pick the tape.
Yes, Morty. Tape is the answer. It's like duct tape for your life. Just stick it together and hope it works.
And now again, we'll check if the tape is on the box with this camera there. And if it is not, we will try again. If it is, we perform the task. So that's it.
We want to really emphasize that it's end-to-end. So it uses the Mistral VLM for the reasoning of the scene, and then it also uses trained policies for the manipulation.
And I really want to emphasize that it works. We have stellar success rates.
We also made sure that we use the LLM to do the function calling to choose the right robot input.
So just come, you can choose your own blocks. Don't be waiting. And there is other surprise. Yes.
Amazing. Yeah, so that's a full demo of the robots working well together. That's the submission, and yeah, we'll talk a little bit more about the setup, and then maybe towards the end during Q&As we can talk about the funny stories that went on as well. Just very quickly, this is just so you have a sense of what the cameras are actually looking at. The thing that we made sure to really focus on is having a very clean setup. So try and get as little noise within the actual setup as possible. We have loads of different quite bright lights as well, just to make sure that no matter, if we're training stuff deep in the night, which we were doing, and then if we're showing stuff during the day, like any kind of ambient light would have minimal effect on the actual policies and the execution of them. The one on the left, this is the one that mainly we used for actually training the act policies, and the one on the right is the one that we use for the actual LLM to figure out whether we had a successful action or not. Cool. If we go to the next one. Cool. This is a very simple diagram on kind of what's actually going on. Yeah, zooming in, I think is fair. So as you could see during the demo, we had a little portal where you have to tell Rick and Morty what they have to do, and the whole idea is that Rick and Morty are trapped within these arms, and all they're allowed to do is like help us, back for our hackathon. So through the portal, you could say, "Hey Rick," or "Hey Morty, I'm going to this hackathon. I really need a motor, and I really need some tape." We use Whisper to turn that speech into text. That goes straight into a agent. This agent has a bunch of different tools to call, and those tools, it will do some orchestration, like, hey, they want tape, they want a motor. Let me just do these two calls, and it will do that. And those two calls will then really just be calling a particular policy. We then have to, make sure that we switch the policy to the correct robot, kind of on the fly. And then from there, we'll execute it. We've got all these funny voices going on. And then after that, we have that top camera from the last slide that checks whether the actual outcome is correct or not. And if it's not, and you didn't see it through this one, during the final demo, it did do this, where it actually saw a failure correctly. It didn't do it well, the policy. And so if that's the case, we actually retry up to 2 times to make sure that we actually get the result that we want. And if it's a success, great, we're done. And we just go back to the initial kind of voice command, and you can ask it another question or another thing to pack, and it'll help you out with that as well. Cool. Okay.
Is that something?
Yeah, I think it's interesting. It's not updating correctly according to the thing, but it's fine. Okay, go on. Yeah, that's a little bit better. Amazing. Okay, so we chose a Rick and Morty theme. The one thing that me and Aimilios kind of knew from past hackathons that we've done is that there's a couple different ways that you can really score points with the judges. One of them is by doing something technically completely novel. And another one is by having a very succinct, like, finalized product or a very polished product where there's like a bit of a story, there's a bit of a fun element to it. So obviously we did some technically great stuff training the policies, but we thought we could really jazz it up by giving a fun theme, and we went with Rick and Morty. I think we had the right kind of target audience at this particular hackathon. I'm sure at this particular meetup as well, everyone is familiar with Rick and Morty, and I can think of any other characters that would have to travel interdimensionally and perhaps be stuck in some robotic arms. I think these two actually fit the bill quite well. So what we've done is we actually found some models to do these voices quite reliably. Then as you can imagine, if you have some kind of pipeline between it's knowing, there's a command that they have to do, then you have to have an LLM call to figure out what they might say. Then you have to do another call to this voice model to actually generate the audio and then stream it back. That was never going to work. So what we actually did is we had a quite extensive tree of all the different states that our application could be in. So whether there is a particular item that needs to be picked up, whether Morty or Rick is giving a comment to the other robot arm, whether it's something was successful, that we had so many different audio files that we then kind of orchestrate based on what the actual state of the environment or the world is with the robotic arms. So we pre-generated all of that to keep the latency low. The surprise that we were supposed to have is, as you can see on the right, if you look quite carefully, the kind of like mouths are a little bit like there's an added layer on top of it, and then there's a motor behind it. We tried so hard to get this motor to work. So basically, when Rick would be talking, his little mouth would spin or something like that, and Morty the same. But unfortunately, we had some classic hardware issues, so we weren't able to get that to work. But the kind of just the visuals helped the demo a lot for people to visualize kind of what we were trying to do. Cool. Next slide. Well,
So,
do you want to take this one? Yeah.
yeah, so one thing that I guess Martin mentioned we had figured out from before the hackathon, just playing with the arm, is that training models to control the arms is very is really not robust. And not only do you need to really control the environment really well, but you also need to have like high quality data. And so we had done some experiments before the hackathon. We kind of did some experiments in the beginning of the hackathon. But once we kind of did our full data collection round, which kind of went through the night, we tried to go more systematically about it in order to make sure it would actually work. So what we did is we wanted to make sure the judges could move the objects around the table and that the policy wouldn't just break. So we kind of picked a bunch of positions. We made sure to cover all the possible rotations of each object. And then one thing which is recommended in the robot project and more generally is to have multiple samples for each position. It kind of helps reinforce the expected behaviors. And then we had, as you saw in the demo, 4 objects which were chosen strategically so that they would look hard to pick, but were actually quite easy to pick. And yeah, so that kind of gave us a total of 400 training trajectories and 100 for each of the policies. And then we kind of did a bit of a trick, which is that we always place the same 2 objects on the same sides, so that we only had to train each arm to be able to pick up 2 objects, and we didn't have to train each arm to pick up all the possible objects. Now, in terms of actual time, collecting 100 samples in practice took about an hour, assuming everything went right. And so it was kind of a total of 4 hours of data collection. And then training a policy, I think, was around 1 to 2 hours for training it long enough that it would perform well. And that training was happening on a cloud kind of compute service that was sponsoring the hackathon. And then inference, actually running the model for the demo, was happening on the MacBook processor. And I guess something to mention is that there's kind of like 3 main policies that were, or models that were being used to control the robots. The smallest one, which is the one that we use, is called ACT. And it has, I believe, something like 300 million parameters. And then there's kind of 2 others which have been mentioned as well, Pi0 and Groot by NVIDIA. These are much larger models that are supposed to be much more robust and generalize a lot better. But if we go into the learnings, that I see that not necessarily the case. So yeah, just have listed kind of a bunch of learnings and challenges that we faced training these policies. One thing we found is that the camera, which is sitting on the gripper of the arm, so that's the one that helps the robot kind of tell whether it has been able to grab the object or not, is actually not as critical as we thought, because for one of the 4 policies we trained, we accidentally forgot to plug the camera. And so we kind of found out that it was working accidentally without having that camera, which was quite a surprise, because I think some of the guidance from, I don't remember who, but there was a lot of guidance coming from everywhere. And some of the guidance was that the gripper camera was critical. So yeah, Martin mentioned that teleoperating at a kind of consistent speed was important. Otherwise, it would just skip frames. I think the recording frequency was 30 or 60 hertz. Another thing we found was that it was very important to start and stop the recording at the right times. Because if you had, let's say, a 60-second recording of a trajectory, and 30 seconds is picking up the object, putting it somewhere, and then you spend 30 seconds in the rest position, the model will just learn that most of the time it's resting, and so it wouldn't do anything when you actually run it. That was kind of like a thing that we found out actually before the hackathon. Moving slowly, ample moves, avoiding obstacles kind of largely was important because in practice the policy would make some small errors, and so if our training data went very close to obstacles, the main one in our case was kind of the box itself that we had to put the objects in, it would end up like hitting the box and like pushing the box away. That was a bit of a problem. Yeah, this is a bit of a detail. Not falling asleep, I think that we had some trouble. And then, so the way these models are trained is with kind of an approach called behavioral cloning, where you record all these examples of how an expert would move the arm, and then you train the model to replicate these expert trajectories. But one problem with this is that anytime there's a small error that happens when you actually run the model, then you're suddenly out of distribution, and you don't, like, the model doesn't really know how to recover from that. So if it makes a small mistake, let's say it grabs it the wrong way, it grabs the object the wrong way, then it doesn't know how to fix that. Or if it, yeah, I mean, there's many ways you can go out of distribution. And we didn't really have a way to address that because, one way you might think to fix it is let's collect data where something wrong happens, and then we show the model how to recover from that. But then that means you're training it to get in the place where it does something wrong in the first place, which is not what you want to do. So yeah, that's kind of an inherent limitation of behavioral cloning, and there's other approaches to training these models, but they're more complicated. Some other challenges. So there's kind of two ways to control the arm and get data. One is like by using a second arm, and that's kind of teleoperating with that. But you can also use a VR headset. And for us, it would actually have been very convenient because with a VR headset, you can kind of have two controllers, and like you're actually doing the thing with the two arms. And we did try that in the beginning, but because everyone at the hackathon was on the same Wi-Fi, that was overloading it, and so the latency for the teleoperation was too high, and so we had to give up on that. One other issue that we had was that the model itself doesn't know when it has completed the action, and so if you have to pick a block and put it in the box, that might take 15 seconds. But let's say the block falls and then you have to pick it up again and put it in the box, that might take 10 more seconds. And this is something that kind of regularly happened. It wouldn't always do it perfectly. And because the model doesn't know when it finished, we had to be very conservative in when we move on to the next action, and just pick like kind of the typically longest time it would take. And so in practice, that meant that the demo would have some idle time between actions, which was a bit annoying. We did kind of think about having the Mistral model constantly check while the action was happening whether it was completed, but that ended up not. We didn't manage to do that in time. As Martin said, there were a bunch of issues due to the fact that we were building on platforms that are very early stage. So Le Robot and Fosfo were the two. Just because it was very painful, I really want to explain what those issues were. Or to kind of give a sense of like how we spent most of the hackathon. So we first started collecting our data with Phospho, which is kind of like this abstraction layer on top of the Huggingface framework. And they have this really nice UI where you can kind of see all of the cameras. You can see all of the signals, like the motor signals. You can have these really nice buttons to place, to click start, stop, to discard episodes. And so we collected a bunch of data with this. We started training a model, and then it failed. And then, we go to the Phospho team. We asked them, why is it? We found out that our data was corrupted, and I guess digging into that, we found out that the Phospho discard button, which had been added like the day before, because all of this is very much in development, wasn't implemented correctly. And so anytime you discard a sample in your data set, the whole data set gets corrupted. So then we got pointed to a script that was kind of like in the Discord channel, which fixes corrupted data sets. But then kind of that script was corrupted itself. It was AI generated or something, and then it corrupted the data set even more. Anyways, lots of adventures like this throughout the night. I think the worst one for me was spending kind of 3 hours debugging why a model that we had trained had the wrong dimension, was failing to load because it was saying that the output dimensions were incorrect. And after spending 3 hours, I just went to kind of the Remy, who's like the lead for the robot framework, and he came to debug at the table with us. And then we found that there was this really subtle bug where if you had the teleoperator, so there's two arms, right? The one which is actually moving and the one that you use to control the other arm. If you had the arm that you use to control connected to your laptop, the model would load correctly, but if you didn't, the model wouldn't load correctly, something that was completely unrelated. Yes, long story short, a lot of debugging random things. And then kind of the main failure modes of the model controlling the robot were just failing to grab the object correctly. That was the most common one. Another issue was that sometimes kind of the object would be too close to the arm, and so the camera couldn't see it. That was kind of a failure of our setup. And just hitting against the box and pushing the box. And I guess, yeah, Martin said the ChatGPT moment is several breakthroughs away. I think this is definitely true. And something that was quite interesting is that it seems that the kind of newer models like Pi0 and Groot are supposed to generalize significantly better than the smaller models or older models. But empirically that, or at least in the context of the hackathon, that didn't seem to be the case. So there were a bunch of teams that tried to use these more fancy models, and that worked worse or the same. And yeah, actually the Huggingface team had told us that they had tried to use Pi0 as well with the robot arm, and they had struggled to make it work. So all of this ecosystem essentially is really early, and yeah, that was personally very surprising to me coming from the world of text processing, where the models really generalize so well and everything works. Yeah, and then Martin, do you want to?
Yeah, absolutely. So luckily, Hugging Face actually has posted all of the different demos on that particular URL. We can probably add it to the chat in a bit, so you don't have to like write it down right now. That's totally fine. But there are two. Actually, I don't think we mentioned it, but we came in third. So we were gonna show the top three, but we were number three. So we had number one and two here. Number two was a team that did Who's Who, which was very, very cool. Where basically you had like a similar portal like we had, but instead of talk to Rick and Morty, they were talking to the robot here, telling it which characteristics their particular character had, and then it would go about using an ACT model and a small LLM from Mistral to figure out which one to tip over, and it did it seemingly quite reliable. So that was very cool. And again, like I thought the story was quite nice actually. I think it was more around what if somebody with a disability wanted to play this game very badly. Now they have a way of doing that. So that was very cool. And then the other one.
One thing on this one also that I found interesting was that they modified the policy to take as an input the position of the person that they wanted to flip over. So just from a modeling side of things, that was quite interesting.
And then, yeah, we had this one where this was the first place where they had, well, this robot, they had it actually on a Likiwi and to actually drive onto the beach. And they used a small Mistral model to figure out whether there was something on the beach to be picked up. They used an ACT model with a Pi Zero as a backup. To actually pick up the trash and then put it into a little bag that was next to them. But yeah, that was really cool, and I'd recommend going in onto the URL and looking at some of these demos. They're all pretty fun.
Well, that's kind of the bulk of it. I'm sure this was kind of a lot of very jumbled information, but if you have any questions, we are happy to answer them.
I got a question for you guys. Thanks for the presentation, by the way. I didn't think it was jumbled. I thought it was really good information. So I'm curious about this, like this Chat GPT moment thing, where it's coming from. Is it just VCs trying to push things and get money flowing, or is it honestly genuinely like we might be getting close? And if we do have a ChatGPT moment, what does that even look like in robotics? Because when I think of ChatGPT, I don't think of just the models. Like the models, the models, of course, like they've gotten really good, but there's also the product too. Like everybody has access to ChatGPT. So what does that look like for robotics? Is it like everybody has a robot in their house and the models are so general that people can just talk to the robots, or what? I'm just curious if you guys got a sense of what that might look like if we get a GPT moment. Is it more on the technical side, like the models are good, they're good general models? Like, is that more realistic, or what do you guys think?
Yeah, so I can comment on the kind of VC perspective, and I think maybe Aimilios has a good opinion on the model side of things. Yeah, it very much felt like quite pushed by Entrepreneur First. I think it was mainly them, and then all of the speakers, including the Huggingface people as well, kind of mentioned like, man, like there's still a lot of breakthroughs and a lot of problems to solve before we have anything like a ChatGPT moment. I guess there's two things that people mention on what a ChatGPT moment looks like. One of them is, when it's kind of self-replicating in a way, so you can have that like moment of that tipping point of everyone can have a robot because a robot can build itself, and then the other one is something being very generalizable. But maybe Aimilios has a good call on this as well.
Yeah, I mean, I would say the reason people are hopeful for a ChatGPT moment is just that there has been a ChatGPT moment in other type of modalities and aspects of AI. And it kind of intuitively makes sense why that would translate to robotics as well, right? Because robots need to be able to understand, to have visual understanding and to understand commands. But to me, coming into this hackathon, I didn't expect that it was so challenging to actually do the low-level coordination of the motors. I anticipated that, getting some of the higher level thinking would be a problem, but that was essentially trivial. Yeah, the Hugging Face team, I think, mentioned that kind of what they're working on is what you said, is everyone having a robot in their home. So that's what they're trying to do with this arm. I don't know if I buy it personally, like, but yeah, that's their vision.
Thank you.
Ask a question, just very sort of practical in the way. Basically, when you talked about the issues around latency and the use of Wi-Fi, when you're in a crowded environment, and by the way, well done on winning, being able to cope with that. When one is thinking about replicating these things, whilst at a hackathon, okay, there are issues, lots of people together, and you have to have a workaround. But if one is then thinking about replicating this, you talked about, the real world and robot in everyone's home, etc., etc. These considerations are going to be really important. Has anybody started talking about dealing with some of those smart basics?
Sorry, I didn't quite hear the last sentence. Could you repeat the last sentence for me?
Sorry, yeah, I said, has anybody started thinking about what I would call the smart basics, being able to deal with those issues of something working in a non-controlled environment where you have got issues to do with Wi-Fi and latency and all those things. If one is going to scale this up, alongside all the great work to be able to power, in this case, the arms, you've got to have that side, if you are at a tipping point, to deal with some of the practicalities, to be able to enable people in real life settings to work with it.
Yeah. So when it comes to the Wi-Fi connection and latency there, I mean, I feel like that's probably a more hackathon specific problem, more than anything to do with somebody wanting to train their own things or use these arms in their own environment. When it comes to actually, everyone, probably about 30 or 40 or maybe 50 policies were trained during this hackathon, right, by different people. And I'll tell you one thing is that even when we were training our policy, we had a golden rule of nobody touches the camera. Like not a single person touches it, right? Because we were also incredibly scared of any kind of like noise or change, kind of screwing up the policy itself. And so when we go back to the question, like, is anybody working on these smart bases, making sure it's somewhat generalizable? I think people are working on it. It's just that we've not been able to use any of those models yet. And we weren't able to kind of see that generalizability quite yet. Yeah.
Thank you. Points. Yeah, good response.
Hi guys. So great job with the hackathon, and well done for getting third place.
Cool, thank you.
I just wanted to ask about the hackathon itself. How much preparation do you think that you spent and working on maybe some of the software or learning something new before you actually attended? And because of the fact it sounds like you spent a lot of your time training during the hackathon itself. What kind of things were you able to bring to it in such a short time?
I would say, so we borrowed the arm from Dave, and then we spent kind of a couple days just playing with the arm itself, just trying to get familiar with the frameworks from Huggingface. Everything else, I think, we did in the hackathon, so kind of working with LLMs or VLMs, like the actual software. These are things that were pretty fast to do because it's kind of things that both Martin and I are doing day to day. Does that answer your question?
Yeah, it does. I think it just basically shows that you guys were absolutely fantastic, because it sounds to me as you had a lot of work to do there to get to that level. But it looks like you do it really well. I think most people, when they come to hackathons, are usually quite prepared, but it varies, I guess, on the level. So I think because of the fact it sounded like you never done anything with hardware or any of the robots, it feels like that might have been more of a challenge, but that doesn't look like the case.
Yeah, I'd say look, like the SO100 arms just kind of work to be fair. Like the robot, I think has done a very good job of making it quite accessible. So I think if we really had to mess around with hardware and maybe solder things and really figure stuff out on our own that way, I think we would have had to spend a bit more time preparing. But yeah, like once we got the arms from David, which are already pre-assembled, we got the teleportation working within, I don't know, 10, 30 minutes, something like that. And then we were able to collect like a very quick data set. We're like, okay, cool. Like we've gone through the motions now. So I'd say it's a massive props to the Huggingface, the robot team as well.
That's great. Well done, guys.
Thanks.
I'd kind of like to follow on from Ho's question a bit because one of the things that we struggled with robot hack is okay. Well, we came up. We used to organize hackathons around a particular robotic platform, which worked when we had the sponsor who basically was the company who made that platform because they would just lend us a bunch of robots. Now that company doesn't essentially exist anymore. We don't have that kind of that thing to rely on. So we've been thinking about, okay, well, how could we do a hackathon? Going forward, it means we need a much more accessible platform. And we've been thinking about a bunch of things like self-driving cars. You can build those up relatively cheaply. But the SL100 arm does look quite appealing as it's actually relatively low cost and it seems so robust. So I'm guessing the answer is maybe yeah, but I mean, do you think that this is a platform that's ready for other people to run hackathons based on it?
Yeah, I mean, I'd say so. I'd say so. Like you said, it's low cost. It kind of low friction for new people to get used to it. It just depends on if it's suitable for the kind of things that you want to hack. Because we weren't able to get much further than picking up a block and putting it in a box. And even if you look at like most of the other ones, like that is kind of the extent of what you can do with it. The one thing I just want to put here because I got quite this is something that I've done a couple months ago that got me kind of excited. I went to this very low level like Robo Wars thing, and they used to have it at my university as well. So if you want something low cost, that's kind of fun, and you can really compete with each other as well. You could even do like a small Robo Wars hackathon. I think the kit costs maybe 75 quid or 150 quid, something like that. So also like quite manageable. And that could be a very, very fun hackathon. I know if you do that one, and I've got availability, I'd probably join with a friend of mine because we were supposed to build one of these a while back.
I think for me, I had to really reset my expectations going into this because I think when Martin said, let's do a robotics hackathon, and then I saw that they use a robotics arm, I thought, oh, we can do so many things with a robotic arm. And then we started looking at, there had been like a couple hackathons, I think in the leading months, where the SO100 was used. And I was really confused. Why is everyone picking up blocks? And turns out there were some reasons.
Yeah.
You say that's a limitation of the hardware, or is it just that it's so hard to train these things to do anything more than pick up blocks?
Training piece. Like, yeah, I didn't anticipate the models would be so well far behind what I'm seeing in other parts of AI. And yeah, so this is kind of why we just try to make it more interesting by adding things that were not related to the control. Yeah. But I think if you have more time than a hackathon, then you can start doing more interesting things. Like if you can, the problem with the hackathon is you don't have time to fail. So you don't have time to experiment. And, training Pi0 takes 12 hours. So you only get one shot during the competition. But if it's like a week, then you can try a few things. You can try to be more ambitious.
It's related to that, actually. I forgot to ask, how much equipment and I suppose what was the split? What did you guys take along? What did you have available to use for yourself? Or what was provided at the hackathon itself in terms of the cameras, facilities, anything like that, and of course the stodgy Wi-Fi.
I think all they provided was actually, Aimilios, do you remember? Was it one arm or one arm and one operator?
I think both, yeah.
Yeah, and then we had some team members that had one extra arm, I think, that allowed us to use two arms at the end of it. We also bought a separate camera for like the kind of environment checking camera as well. But yeah, the main thing that we got from them was one complete SO100 arm kit, basically. Pre-assembled as well.
Okay, so it sounds like the only thing, if you look back on it, you probably would take it either a more powerful computer or some kind of external GPU to do some more training.
Yeah, so we did struggle a bit with that because initially we wanted to train by a more sophisticated model. And we did have access to kind of this cloud compute service to train it, but then to run inference, it's not really easy to do that with a cloud service because you need to kind of set up the whole communication, like sending the images to the server, while the framework kind of already supports doing it locally if you have a GPU. So NVIDIA was actually a sponsor of the hackathon, and they had this box, but it was kind of shared across all teams, and it was a bit messy to just take it over. So yeah, we kind of just ended up using ACT, which enabled us to train with a GPU and run without a GPU.
Yeah.
Something I found very interesting, and I guess relates to my personal lack of awareness about the space, is that when I told kind of the Huggingface guy that we were going to train Pi0, he was like, "What are you doing?" Like, it kind of sounded like that's not realistic for a hackathon. And yeah, he also said that essentially the small models are just as good for the most part, which was also a surprise. To be honest, I don't think I really understand this still. What is the disconnect between kind of the big models being really good on paper and then not really being really good on a hackathon context? I think I need to dig deeper.
Yeah, that I'd say that is surprising to hear because when Pi0 came out, there was like a blog post and other like marketing around it, and it made it sound like, oh yeah, this is the first foundation model, you know. So I think I would have gone and, if I had attended, I would have had that same expectations. Like, of course, we're using Pi0. Like it's the first foundation model for robotics, but it sounds like it wasn't quite that. Or at least there's just it's just not if you try to relate it to what that means in the LLM space, it's not quite the same.
Yeah. I I think I've been very confused about this. Like, I guess if you think about the LLM space, the nice property is that everyone is working in the same output space, right? Like it's text. While models, even if it was like perfectly generalizable, you wouldn't be able to use it because it's never been trained on this, right? So at the very least, you kind of need to fine tune it on the specific hardware that you use, even if it's like incredibly good at generalizing, unless it has like a mechanism to learn on the spot as it makes mistakes. But I guess that's beyond current capabilities.
Back to my practical type questions again. One of the things that you said to me, Jos, was that if you'd had more time, that could have helped. I appreciate, the idea of a hackathon generally is everybody assembles in the same place. You've got a limited time. That's the element of competition. Is there a way, I mean, just what do you think, and what other people think, that in the longer term, is there a notion of almost a movable type hackathon that people are given an extended period of time and even the opportunity to do some of this virtually to help people, we went back to the whole point of overcrowded Wi-Fi connections, and where people can collaborate with one another. Is there an argument, given that And here we are, talking virtually, whilst of course one doesn't want to detract from the sheer joy of gathering people together to do things in real time. We've had too much of this, I know, in the lockdown era, etc. But just in terms of the actual practicality of learning, what do you think? Would it have benefited you to have a longer period with kind of check-in points? And as I say, some of it not necessarily, because the impracticality of keep going backwards and forwards to the location, to be able to do at least some of it, if not all of it, virtually.
Actually, I think I saw that Huggingface is doing a virtual hackathon for the SO100 arm. So you might have some foresight there.
It's just a thought.
I mean, I guess a lot of hackathons I've seen have been virtual. I guess the challenge of robotics, right, is that you need some hardware, and you either got the organizers, giving a lot of trust and saying, okay, you can just take my arm for a month or so, please bring it back, or or maybe like you say, having an extended thing where it's actually multiple weekends and you have like a check-in point every weekend. But then again, that's asking quite a lot of the organizers and the attendees, I guess.
Yeah. Yes, I know I'm not being very practical, but it's just just a thought, as I say, reacting to the one made. And it's quite true, isn't it? It's something as complex as this. You do need longer to be able to learn, to experiment. And in a way, perhaps one could push the boundaries even further with that. But okay, that's perhaps a luxury for another time.
No, I think it's good to throw out, right? I mean, it's good to consider all the options. Maybe such a thing is doable if we could figure out the practicalities of doing that.
Yeah.
I mean, I guess maybe if the simulation environment was decent, you could say, okay, well, we're having a month-long hackathon. The first 2 weeks, just run the simulation, turn up on the weekend, and use the physical hardware. But again, you need a simulation that's good enough that you could have some confidence that if it worked in simulation, it would work in the real world, right?
Did they give you guys access to any documentation that ahead of time before the hackathon? Was all that documentation public, or was some of it sort of closed doors? It's all still too new to really release.
I'd say it was all public. I can't think of anything that was it was just Entrepreneur First giving us the hackathon information. It was nothing to do with technicals. So it's all just the Phospho and the Le Robot documentation. And I mean, unless Aimilios, you can remember something that they gave us, but I don't think so.
It was all public. It was all also very new. So for example, Phospho, they had launched their platform the week before, and so during the whole hackathon they were just
okay.
It's too late as the bugs came in.
There's a question in the chat. It says, I didn't understand why you did an environment check if you trained the model to recognize the blocks.
So the environment check was just because Aimilios mentioned earlier that it's impossible for the policy to actually know whether it's done its job successfully or not. So we just set it to, I think it was 20 or 30 seconds. So it'll try to pick up the block, put it in the box, and then it'll do that for 20 seconds, and then it will go back to its original state. But there's no way for the robot to know whether it's done it well or not, and that's why we had to have the environment check.
Can I dig into that a little bit more? Because obviously, presumably, while it's performing the action, the robot is using the camera, or is it not? Is it not using the camera while it's actually moving the block? Because if it's using the camera, surely it's getting that feedback as it moves. That it's picked something up, it's moving it, and it's dropping it.
No, so I mean, basically, if you have the robot arm and it's trying to pick up this block, and let's say it misses and it lifts itself up again, it will try again. It will keep trying again until its time runs out, right? And then if the time runs out before it was actually able to put it into the box, then I mean, tough luck. There's no way of knowing whether it was successful or not. That's why I need to have like this kind of third party that has a look at it that says like, oh yeah, it's in the box or it's not in the box. So even though the policy is somewhat self-correcting, where it will try again and try again, because the policy doesn't have like a Boolean that says, hey, I've been successful or hey, I've been unsuccessful, you do need that external validation.
I think you have a point though, Dave, that probably a better orchestration would be to just have the policy run until and then just have constant checks and then just interrupt the policy once we detect that it was successful.
Yeah.
But yeah, we went for something a bit simpler.
I mean, we thought about it as well. It's just honestly, it was more of a time constraint not being able to do that. We spend a lot more time on the getting the voices right than on this kind of like extension on making it slightly smoother. Yeah.
Besides the training and like the data collection stuff, were there other parts of the tech stack that you guys enjoyed? Like I saw there's like the agent part. Did you two work on that part, or did you have a team member kind of do the agent? And was there a framework involved with that part, or was that like straight Python calls to, you know?
Yeah. So straight Python calls. I think I mainly did the agent orchestration stuff. Just honestly straight Python calls. I tried to use even the SDK from Mistral, but it kept screwing up. So in the end, it was very raw. And it worked. Like it wasn't too crazy difficult. It just kind of had to work and integrate with all of the hardware as well. Aimilios made sure that I was able to, use an actual function call to actually change policies, which wasn't trivial either. And then it was just normal coding of making sure everything works well and like different, the audio gets called and you don't have audio like, double playing or playing on top of each other because like the timing wasn't quite right. There's just a couple of things to get the polish there. But yeah, all very like fairly basic in a way. Yeah.
Yeah, that's cool. That's interesting to hear and cool to hear because that's another space that you hear a lot of like there's a lot of tools out there competing, and there's even like VC investment in that space too with like tooling and stuff. So to hear that you were able to do something pretty good without all that other stuff is yeah, it's kind of a nice insight. Yeah, thanks.
Yeah. No, I'd say yeah, there's lots of tooling everywhere. But one of the reasons why tooling sometimes is a bit difficult, because with my last company, I used Llama Index for building like a very fancy RAG system, is that, the tooling often doesn't actually keep up with the technology. So you'd have to like keep jumping versions or a new model comes out and it doesn't quite have like that model support in tool yet. And so what I found there as well from Llama Index, I slowly but surely moved away from it myself and started almost re-implementing things just because I needed to be at like the cutting edge of what I was doing. So that's definitely a consideration. Maybe that has kind of slowed down a little bit just because a lot of like the innovations such as function calling and I don't know, I guess the model context protocol is the newest one. It might have slowed from the initial like jump in features that these LLM providers have. But that was definitely something I struggled with when using some of these.
Cool. Yeah, thanks for sharing.
In terms of more general learning from the hackathon, is there anything you thought that worked really well in terms of how you as a team work together and how you just basically did the work, or conversely, are there any things where you think, wow, if we had to do this again, we'd do this differently?
Things I would have done. I think one thing that at the beginning is that we were discussing like what particular idea to actually execute on, and that was quite a long discussion between all the team members. And maybe just having a bit more clarity ahead of time on exactly what we're going to build, all being alignment of that probably is a little bit easier. I think that's the main thing. Other than that, especially like me and Aimilios tend to work quite well together. Yeah, that's it. Just make sure you're super clear on the idea.
Yeah, I mean, I think it's always I had done a bunch of hackathons during university, which were very different because I kind of knew everyone in the team. And, we got a chance to discuss what we wanted to build ahead of time. So in this case, it was a bit different because I only knew Martin, Martin knew me, but then there was kind of like a Discord channel where you could find people to team up with. And so we had found a team, but we only had to coordinate everything kind of the night before, and that was, not super easy. Yeah, one thing that I quite enjoyed was that one of our teammates, who I guess was more on the hardware side of things, kind of dropped on us at the end of the hackathon that
Yeah.
his previous company had just been acquired by Huggingface like the same day, and so that's why he was there. That was kind of a nice ending to the hackathon.
Yeah, very cool.
You might have seen it in the news. It was like they do this humanoid robot, and now kind of it's called Pollen Robotics, and Hugging Face is trying to get in the space of open source robotics, so they acquired that company to have their open source humanoid.
Cool. Anyone have any last questions? Okay, I will end the recording then. So yeah, Martin and Aimilios, thanks very much for turning up and talking. I hope I didn't twist your arm too much. I do really appreciate you coming and spending some time with us today. Yeah, congratulations on third place in the hackathon. That's really good.
Thanks for inviting us.